This conference will now be recorded.
All right, this is some examples from the Unit 4 notes, things that we've skipped over. Starting with the very first section, I wanted to do problem number 14. So it says, find the profit function for the given marginal profit and the initial condition. So they've given us the derivative, and we're going to work back to the original profit function, which means we're going to take an antiderivative. So let me get my pen. So we're going to be doing that the original profit family of functions came from taking the antiderivative of negative 18x plus 1650 dx. So remember, we use our power rule kind of in reverse here for the antiderivative. So you would add 1 to the power and then divide by that number. And we would just add the x here since it was a constant. And this is our p of x, and then we have to remember to add the plus. Now, because this is a profit function, we don't want to use c for this constant because it might be construed as cost, so we're going to use plus k. I can reduce that first term. That would be negative 9x squared plus 1650x plus k. So remember, this is a family of functions that all have this as their derivative. They gave us an initial condition that when they plugged in 15 for x, they got 22,500 for p. So we can plug that in for p and plug in 15 for all of our x's, and we'll be able to solve for that very specific k. So this is 22,500. This is going to be negative 9 times 225, so that's going to be, hang on, let me double check that. So let me make sure that that is right. 15 times 15 is 225, and then times the 9, so it's negative 2,025. And then we have to do 1,650 times the 9. That is 14,850. Let me double check that one more time. It was times 15, and I think I typed in 9. So 24,750. I need to erase that. So I didn't think that looked right. So let's get the pen. 24,750, and then plus k. All right, so we're going to move some stuff around. I'm going to add the 2,225 over, and then subtract the 24,750, and that gives me a k of negative 225. So when we write down our formula for our profit, it would be the p equals, this would be negative 9x squared plus 1650x minus 225. All right. Moving to the next section, 5.2, we skipped over some of these antiderivatives. So we want to go through those, mostly the evens. A lot of these are going to be U substitution problems. So let's look at, this would look like this is the complicated part down here. So remember, we let that be our U. So just the part inside the parentheses. The du, so that we can substitute, is the derivative of this, which would be negative 4x, and then we tag on the dx since the variable is changing. So that looks like we already have what we need. So if we split that into two pieces, because you can bring that negative 4x out to the side, then that's going to be my du, and this is 1 over u squared. So that allows us to integrate a little bit easier. You could rewrite that as u to the negative 2 du. We use our rule for taking an antiderivative, so we add 1 to the power, and then we divide by that number, and we put our plus c. But that's really negative 1 over u plus c. But then we have to remember that our original problem was not a u, it was the 1 minus 2x squared. So my answer for this one is negative 1 over parentheses 1 minus 2x squared, and then plus c. So there's the answer to that one. Let's look at number 4. Let's let the inside be the one that's being squared on that, because usually that's the part you want to replace with the u. And this may be a chain rule, so let's check. If I take the derivative of that, this would be 3x squared minus 3. So it looks similar to this, except, and that would be a dx. We have x squared minus 1, but if we multiplied them both by 3, then we could get it. So if we multiply the inside by 3, we'll have to counter on the outside with a 1/3. And remember, you only multiply just the part that you need by that. You don't multiply everything by 3. So that's what we get. So this is now 1/3 antiderivative of u squared and then du. And then this would be u to the third over 3 with a 1/3 in front of it plus c, or u to the third over 9 plus c. We also want to replace this back with what it originally was. So this would be x to the third minus 3x all raised to the third power over 9 plus c. So there's my antiderivative. Okay, we actually did 5 and 6 in class. I'm going to do 7 and 8. So for 7, it looks like if we're trying to do a u substitution, we would let this inside part under the bottom be the u, since it's the cubed part. Then du would be 2x dx. We have a 6x. If we could change that to a 2, we would have it. So we're going to divide the inside by 3, which means we're going to multiply the outside by 3 over 1. So we're doing 1/3 on the inside and 3 on the outside. So that makes this 3 integral 1 over 7 plus x squared cubed, and then we'll have a 2x dx, which is what we need here. So this would be 3 integral of 1 over u cubed du, which we would bring up as u to the negative third when we do our powers. So this would be u to the negative 2 if I add 1 power, and then we divide by negative 2. We have the 3 on the front, then plus our c. I would want to make that negative 3 halves, and the u squared is going to move to the bottom, just so we have our negative exponent taken care of. And then we would write our final answer as negative 3 over 2 times 7 plus x squared squared plus c. Okay, and then the last one on this little group, we would have that the inside of that is 14x plus 1, and the du would just be 14 dx. So we already have that, no adjustments needed. So this would just be 1 over the cubed root of u du, or we could say that that is u to the negative 1/3 du. Add 1 to the power, that would be 3 over 3 plus that would be 2/3. And then remember, we have to multiply by the reciprocal since we're dividing by that. So 3 over 2 plus c. So this ends up being 3 times 14x plus 1 to the 2/3 all over 2 plus c. That's acceptable to me, or you could turn it back into a radical if you want. It could be 3 cubed root of 14x plus 1 squared all over 2 plus c. That's another way you could write that one. All right, let's look at number 10. And I'm sorry for the sniffles I have tonight. It says find the demand equation function x equals f of p that satisfies the initial condition. So this time they're taking their derivative with respect to p instead of with respect to x, because you notice the dp is on the bottom. And they did give us an x and a p so that when we get to the end, we'll be able to plug in. So that's like our ordered pair. So we're going to be finding f of p, the big F, which remember this stands for x according to their definition. And we're going to be taking the antiderivative of this function. So that is, let's pull it out to the side. So this is 1 over p squared minus 16 to the 3 halves. I'm going to move that negative 6,000 p to the back. And this is dp this time, just so I can see how I need to adjust this. So if I'm doing a u substitution, u would be the p squared minus 16. du would be 2p dp. So we have way too much inside here. We actually need to divide this by negative 3,000 to turn it into a 2p. And whatever we do inside here, we do the opposite. Since we divided, we're going to multiply out here by negative 3,000. So my big F of p is negative 3,000 integral of 1 over, now this can be u, so that's u to the 3 halves times du, because this is now 2p dp. And then we would move up that u to the negative 3/2 so that we can use the power rule for antiderivatives. So f of p is going to equal negative 3,000 times, if we add 1 to that, that'd be adding 2 over 2, so that's going to be u to the negative 1/2, and then we multiply by the reciprocal of that since it's getting flipped, and then plus c. So this means that f of p would equal, that's going to be negative 2 times negative 3,000, so that's going to be 6,000. And then we have u to the negative 1/2, so that's going to move to the bottom and be square root of u plus c. And then we know what our u is, so we need to plug it back in. So 6,000 over square root of p squared minus 16 plus c. Now that gets us our family of functions that had this as the derivative. We wanted a very specific one. We wanted to plug in 5,000 for our x, which remember this guy is x, and 5 for our p. So this would be 5,000 equals 6,000 over, that would be 25 minus 16 under the square root plus c. 25 minus 16 is 9. So that's going to be square root of 9, which is 3. So 6,000 divided by 3 is 2,000. So we get 5,000 equals 2,000 plus c. So c equals 3,000. So that means my final formula for a little f of p, the original function, would have been 6,000 over the square root of p squared minus 16 plus 3,000. So there's the original function. Okay, so that gets us to section 5.3. We did pretty much all of the first page here. So we're looking at the second page, the log rule ones, and we skipped some of the even ones on this one. So let's look at 8. The first thing I would notice with 8 is you can reduce this. So this is just 3 over x dx, or 3 integral 1 over x. When I was pulling out that constant, it helps people see that this is the 1 over x, which means it's natural log of x. So this is 3 times natural log of the absolute value of x plus c. So we're using this integration rule right here. For this one, it's got a denominator, so I'm going to try to use a u substitution to see if it can be written as a natural log. So I'm going to let u equal the denominator, and I'm going to take du of that, so that would be 8x dx. So it looks like I need to times the inside by 8 and multiply the outside by the counter, or 1/8. So that's going to be 1/8, and then this would be 1 over 4x squared minus 5 times the 8x dx. So that is 1/8, 1 over u du. So that's natural log of u, so 1/8 natural log of absolute value of u plus c. The only thing we have to remember is that u was 4x squared minus 5. So absolute value of 4x squared minus 5 plus c. So there is my answer for that one. When we look at 12, I want to say I did 12 in class. I think we did. So I'm going to skip that one. I believe we did both 11 and 12 in class. I want to jump over and get a head start because tomorrow in class we're going to do 13, 15, and 16. But I'm going to skip 14, so I'm going to do it right now. This directions up here say that you have to use it doing long division. You don't actually have to do that here. It is long division, but because it's a monomial, you can just do it by regular division, reducing. So we're not going to get anything too complicated here. So that would reduce to 4x, because 4x cubed divided by x squared would just be 4x, minus 4 minus 9 over x, because this one has more x's on bottom. So I just split it into 3 separate fractions and reduced them. Using our integration rules, this would then be, sorry, let me back that up. We don't need the integral anymore. So this would be 4, raise the power by 1, and then divide by that. This would be 4 to the x. This one is going to be negative 9, and then it's 1 over x. So that would be a natural log of x. So this is 2x squared minus 4x minus 9, natural log of absolute value of x plus c. So just because something looks complicated doesn't always mean you need the U substitution. For example, the monomial in the bottom, I did not need it. If I have a binomial in the bottom, I'm much more likely to try the U substitution. Whereas if I have a monomial or a single term in the bottom, I'll try to reduce first. So that is the end of where I wanted to get, and we will start off on this page again tomorrow and finish up and move on to section 5.4. Have a good evening.